Hi everyone. Good morning to you all. It's 5 minutes past 10 now, so I think we should get going. Just before we start, I have no indication anymore of whether my voice is coming through. Could people please type something in the chat just to let you know if you can to let me know if you can hear me okay? Perfect. Thank you, Mark. Brilliant. Thanks. I also put my camera on just for the period of saying hello to everyone. Hi there. So maybe you can see a little picture of me at the bottom of your screen now. Hopefully, I'll just say hello to everyone. Loud and clear. Perfect. Um, yes. So yeah, the older version of Blackboard had a nice little thing in the microphone icon at the bottom, which had a level indicator to show you that there was actually some volume coming through, but that seems to have disappeared. Unfortunately, that was actually quite helpful. Anyway, thanks for confirming that my voice is okay. I'll just say hello to everyone as we get going. So my name is William Lucas. I work as an architect at EPCC at the University of Edinburgh, and 50% of my time is spent on ARCHER2 CSE. So that's the group who help people with installing software, understanding performance, basically anything on the computational science side of things. So yes, and Fortran happens to be my preferred language, my language of choice, going back all the way back to when I was in an undergrad. So hopefully I'll be able to help you learn something new or understand new ways to use Fortran in this 3-day course. Okay, brilliant. Okay, let's bring up what we want. So I have two screens. I'll switch between them as we need. One has a terminal, which I've already got logged into ARCHER2. The other has the material, and I will just I'll show you two ways. I'll just put a link to the material in right now into the chat in case you just want to follow that. But I'll also just show you how to find the material from the ARCHER2 website in case you lose the link for whatever reason and just want to navigate back to it. So if you just go to the ARCHER2 website and then to the training at the top, the training item at the top menu. And at the moment, we're on upcoming training. And you can see Intermediate Modern Fortran is there. And you can scroll down and click on course materials here. And this brings you through to the same page. In the future, what we do is we, of course, move items out of upcoming training and they go into past course materials. So probably at the beginning of next week, I imagine, this course will disappear from upcoming training and move to somewhere at the top here. But again, you'll be able to click on the course name, just clicking on data carpentry, for example here. Let's try any one of these. And you would then be able to follow through to the material again. So I'll close that. So here is the actual material. And what you may also want to do is take note of this link here. So so it does say in the course description, but this is this course assumes that you're already pretty decent at Fortran. You aren't a beginner. That being said, of course you always may want to just touch up on it as a whole, or there may just be specific things that you've forgotten. In that case, it's probably covered in our intro to a Fortran course, and that there's a link to it just here, which you may want to just have open as a reference, perhaps. And this was a run I did back in March this year, the very start of March. And this, starts from Hello World, so goes through from no Fortran at all up to well, just starting to brush on object-oriented coding, which is really what we get into in this course. So it goes from nothing up to a decent amount of Fortran. But just in case there are specific things that you aren't sure if you may want to come back here and use this as a reference. So I think it's a good idea just to be aware of that. Is there anything else worth mentioning just here? Well, I suppose it is worth talking about ARCHER2 quickly before I actually talk about logging on in the first session zero. So we use ARCHER2 for this course, one, because it's an ARCHER2 course, that's where the funding for us to do this comes from. So this is an ARCHER2 course, ARCHER2 being the current UK national supercomputer. But also, if you do use ARCHER2, and all of you should have had invitations to create accounts, it means that you can log onto the system, and we've already got a very nice setup using environment modules, which allow you to quickly load different Fortran compilers, and these are all set up and ready to go. And that can be helpful. I'll show you what happens in this course as we switch between different compilers, because often they give you different error codes, error messages. Sometimes they also fail in different ways, and this can be helpful in working out where something's going wrong. Often an unhelpful error message from one compiler can actually become helpful in a different compiler. So this lets you just experiment with that firsthand and see what happens. It's also just a known environment. So if things go wrong, it gives me a little bit more of an understanding of where you are, so I can maybe better help you sort it out, fix it. But all of that being said, there is nothing at all either to stop you from just using a Fortran compiler on your own laptop or desktop computer, because we don't do anything demanding. We do no big jobs. We do nothing parallel. We run ultimately simple programs which are just using slightly more complex syntax to get there in this course. So there's nothing at all to stop you from doing this work on your own machine if you prefer, as long as you have a decently up to date Fortran compiler available to you there. So I would recommend going for ARCHER2, but if you really just can't be bothered, or if it just turns out to be too much of a hassle because for whatever reason at all, you can go ahead and just try this on your own system. So yes, as we go through, I'll try to give lots of opportunities to ask questions. So just before we get going, does anyone have any general questions about this? I'm not seeing anything. Oh, the time schedule. Yes, that's a good point. Yes, I really should have said that. Thank you for reminding me. Yes, so we're following the Carpentries methodology here. If you've taken any Carpentries course, you probably recognize the sort of format that we've got here. We're using their website layout. So we'll be taking an hour for lunch every day. As well as two, let's say 15 to half an hour-ish breaks every morning and afternoon. Exactly when they fall is a little bit movable. Of course, we want to have lunchtime sort of 12, 1 o'clock-ish, round about then, and those break times sort of 11 o'clock-ish, say 11:30, and maybe 3 o'clock or so in the afternoon. As we go through these episodes, as the Carpentries term for the individual lessons here, we might find that some of them take more or less time, depending on how long we need to spend on the exercises, which happen as we go through them, not just in sort of their own sessions, and depending on how many questions we ask. So exactly when they occur, I'm expecting will change a little bit, but we will roughly aim for say 12:30 to 1 o'clock-ish to have our 1 hour lunch break, and yes, roughly 11 o'clock-ish, 2:30, 3 o'clock-ish in the afternoon for our morning and afternoon breaks. And I'm also expecting, so you can see here on the left everything that we've got to get through for these 3 days. So I'm expecting that today we'll probably get down to maybe section 5 or 6 here. And again, we'll do 4 or 5-ish of these each day. I'm expecting each one to take maybe 45 or so minutes, maybe coming up towards an hour. Again, that really does depend on how much time we as a group spend chatting about what's in each of these. It may be that does end up leaving us with a little bit of time at the end of one or more of the days, probably most likely Friday, if we end up making it through these more quickly than I expect today and Wednesday. If that does happen, what I would really invite everyone to do is to actually maybe use this as sort of an opportunity for consultancy. If you're working on Fortran code, and I expect everyone here is either working on a Fortran code or is preparing to work on a Fortran code. If you have any questions about anything that you're doing or anything you would like to know more about or want to learn more about, I would say please use those as just Q&A type consultancy episodes. Okay, yes, so with that, anything else, or shall we get going on to connecting to ARCHER2? I think that's a go. Let me just make this a little bit bigger. I've just realized this might be a little bit small for people. Oops. Trackpads make it too easy to go back. Okay, hopefully that's a little bit more readable. So let's head on to the first session, connecting to ARCHER2. We'll probably breeze through this. Let me actually set up a quick poll. Have you logged into ARCHER2? Because if everyone says yes, then that means we can almost ignore this. So I've just started a little poll. You should see that pop up on the screen. Just to ask everyone, have they logged into ARCHER2? This is anonymous, so please don't feel you have to hold back in any way. If you want to say, if you want to respond in a way that you don't want other people to know for whatever reason, you can just go ahead and press whatever you want. Okay, so some people have, some people haven't. It's almost half and half. So it does actually make, I think, some sense for me to go through this. So let's just end that. Okay, I think that's okay. So we'll quickly go through this. So hopefully what people have been able to do is log on to the safe. You should have had an invitation in the email when you registered for the course to invite you to come on to the safe. Here's the home page. And if you haven't yet asked for your account, you can go to login accounts and then press the request login account button, and you ask for a project. So this is where you say, I'm joining the course that is specifically, I'm joining the project that is for the intermediate Fortran course. So you give it the code TA239, which is what corresponds to this 3-day course. You can see it matches there. You click on next. and then you say which machine do you want, because the safe administers a lot of machines, but this only allows for ARCHER2, so we just go straight through to next. And this is where I won't do it, because this would create a second account for me. So I've already asked for one. It will say this is the username that you're going to get. I will accept the terms and conditions of access, which are again basically what you would expect. Don't make life difficult for other users on the system. Don't do dodgy research. Don't start mining Bitcoin, etc. And provide an SSH public key, and then click on request, and you go ahead and do that. You'll get an email. And then if you do that, I or one of the other people who are managers of the course will be able to approve that, and that will then create it for you. Once you've got that, you'll be able to go to login accounts again, and you'll see TA239, your last name 1 at ARCHER2. It does cut it off at four characters, your last name, which is why I've got Luca rather than Lucas. And then you should see fully enabled. You should see that your SSH key is active. It will take a few minutes. This will be pending for a few minutes, and then it will change to active. And then you can click on view login account password. I can do this because I've already changed it, because the first time that you log in, you'll be asked for the passwords here, and you'll then be prompted to change it. When you change it, at that point, only you know what the password is. The password here doesn't change at all. So it's up to you to remember it. Otherwise, you need to ask for it to be reset, which you can do here. Although most of the time, people nowadays very rarely need that. And finally, also, you will need to set a time-based one-time password or multi-factor authentication token. You click on this button here, and a QR code pops up. And using an authenticator app on your phone, or in your browser, perhaps on your own machine, you scan that code and get the six-digit code, which changes every 30 seconds. Pop that code back into the safe, and it all sets itself up. And at that point, you can use that to log into ARCHER2. As for actually doing that login, let me move over to my terminal. So I've actually already logged in here. Let me make this text bigger as well. I want to make sure that this is visible. So I've already logged in. But if I hadn't, what I would do is I would do one of a few things. I've already forgotten TA239 Luca 1. You can do, so yeah, TA239 Luca 1 at login.archer2.ac.uk, and hit enter. If you need to specify where exactly your SSH key is, there are a few ways of doing this. What I do is I use the SSH add. So I do SSH add, and then I point it to my key. So my key is inside my SSH directory, and it's called ID RSA HPC. And then I just hit enter on that, and it asks me for my passcode. And then this adds my SSH key to the SSH agent, which is a daemon which runs in the background. And whenever there's an SSH request for authentication via key, it serves that key. This I think this is the best way of doing it personally, because it means that you only have to think about where the key is once. I think if you're on Ubuntu and maybe some other Linux this distros, if you SSH in at any point and it finds that key, it will automatically add it to the SSH agent. But if you're on Mac or another distro and you want to forcibly add it to the key ahead to the SSH agent ahead of time, you can do this and then just hit enter, go through this. I've already done it, so I won't bother with that. And then, as I say, it's automatically served up whenever it might feasibly be used. And you can do this for however many keys you actually have. Another way of doing it, you can use I, and then you just provide the path to the key. Again, my key is ID RSA HPC. That's in that directory. So you just do -I, and then path to your key. Alternatively, you can edit your SSH config file, and this is also what I do in conjunction with the SSH agent. And I might actually copy and paste this. In fact, I think I will. I will actually copy and paste this into the terminal, into the chat, because I think this is actually very helpful. This just makes logging in much more painless in general. So assuming that I can copy and paste it in. Okay, I can't. I'll just type it in manually because that's my. And what you can do is you can take what I'm about to put in the chat and copy it into your own config file. And this can help in a few ways. So what you would do is you would edit your .ssh in your home directory /config file. If that doesn't if that doesn't exist at the moment, you can just create it. You can then copy and paste what I've put in there. The host itself doesn't actually matter. This is just a name that we give to it. What matters is the host name, login.arch2.ac.uk, and then that's after the word user, you give it your username. Forward agent yes means that your SSH key, if you're using it, can be moved onwards. And server alive interval 120 is just helpful for keeping the connection alive. If sometimes people I think this really depends on which operating system you're using, but I've seen people who have no issues at all with just staying logged in. Other people just seem to get kicked every so often. But if you put server alive interval 120, it means that every 2 minutes or so, your own SSH client will ping ARCHER2 and say, yes, I'm still here, I'm still logged in, don't kick me off again. You can also add, if you want, into that identity file, and you just put path to your SSH private key. That's just another way that you can tell SSH how to authenticate yourself. Okay, so all of that done. I should just mention setenv. Don't worry, this is just because of the terminal I'm using. Most people will not need that at all. That's not something to worry about. But with that being done, finally, What you can then do is you can do SSH TA239. If I had put host ARCHER2, then I would just do SSH ARCHER2. If I'd done host ARCHER2 TA239, which is maybe a bit long for this to be helpful, you would just do SSH ARCHER2 TA239. But because I had host 239, what I've created is basically an entry called TA239. And I can just do SSH TA239, and it will use all of those options and drop me onto ARCHER2 as this user. So I have a question. What is the TATP code? So the TATP code, I'll actually show this happening. I'll log onto a different account, which I haven't used yet today. This is what happens here. If I log into ARCHER2, and I haven't logged in yet for, I think, the past 24-ish hours, it will ask you what that is. That's your time-based one-time password. That's what you set up on this page here, on your page on the safe, where you go to login accounts and then click on your account name, and there's set MFA token. So this is multi-factor authentication. TATP, time-based one-time password. They're different names for the same thing almost. So if you set MFA token here, do I have an account I can quickly show this on? Maybe something which doesn't matter. Maybe I can just do it here very quickly. If I click on this, it generates this. You scan it, and then so you have on your phone perhaps, and that is it Google Authenticator or Google Auth. I use Microsoft Authenticator just because it works a little bit nicer with some of our university stuff. And you can then add that code, and that means going onto the app and pressing add. So for my app, it's just a plus sign at the top right. And then you scan the code with your phone, and it says, okay, I've added that. And then it will give you a 6-digit number that changes every 30 seconds, and you just type that in. So, for example, it isn't, and then I would click set, and that would add it. Once that's been done, that then stays in my app on my phone, and I can come back here, and when I do SSH ARCHER2, for example, which is another one I've set up, just to show you, that should be up here at the top. So I've just got another entry ARCHER2, which I haven't used yet today. I do SSH, whatever I put in, and the first time that I connect it in any day, it will say, okay, give me your code, and I'll just type 0000000. That isn't right, so it'll tell me that it's wrong, and so on. But if it were right, it would then just drop me into it, and that would be me logged in. Because I've already done it for TA239, our project for this Fortran course, I don't need to do it again. So it says, okay, you've done it today, you're okay for another 24 hours. So I just log in, and it just drops me straight into the shell on an ARCHER2 login node. Okay, does that help everyone? Does anyone have any questions? Is anyone struggling with this in any way? Please just either type in the chat, or you can also send me a direct message. If you go to the chat, you should be able to just type in my name. Okay, I'm not seeing anything. What we can maybe do is carry on, and if anyone's having trouble still, we can maybe talk about it during the first break. I can give you some hands-on help then, if anyone is having any issues getting logged in. But otherwise, it might be nice to yes, okay. Otherwise, we can just carry on with the material. Just quickly for your question, you are required to change your LDAP password immediately. This is something I think this message could be so much more informative than it is. That's good. So you've got past that. Back in the safe, you click on View Login Account Password. Again, this is my old password. It doesn't matter. You just copy and paste this. Take this here and paste it into the terminal and hit enter. And then it will say, great, enter a new password. And you can give it a new password. 99.9% of users will never need that password again. So to be perfectly honest, for most people here, I would say you can type in something and not even bother trying to remember what it is, to be honest. If you ever do need it, you can come back and you can request a password reset. But for now, just take the password that's here, paste it in, and just carry on. Okay, in that case, let me come back here. So we do have some more information here. I think we've actually kind of gone through most of this. This doesn't actually matter too much. What you may want to do, okay, so here's something that everyone should do, because this will be very, very helpful for the course. This command here lets you clone the repository containing all of this this material for this course. So that means the website, but also all of the Fortran example code. So you can copy and paste that command into the terminal. And a very good question, and that will clone it there. A good question in the chat: should we do the work in /work or home if they are lightweight? Of course, for normal work on ARCHER2, basically everything would go in our /work directory, and you can do that. So you can /home/home/work. This is a nice quick way to change over, and you can do that here, because of course everything that's on the compute nodes can only see /work. /home is invisible. It isn't mounted on the compute nodes. To be honest, this course, as I say, what we're doing here is so lightweight that I actually wouldn't bother with that. I would just do it in /home, just because it's that little bit quicker for people, particularly because I think some of the people on this course won't actually be used to ARCHER2 and may never actually need to use ARCHER2 again. I would just do everything in /home. If nothing else, it's backed up, whereas work isn't. So in this case, the work we're doing is so lightweight, so computationally unintensive that we can definitely do it here. So yeah, feel free to just clone into home, and then, and I will put, I will put links to this in the chat as well. All of the exercises are here, so let me just copy and paste this. Okay. I'm imagining this will be lost at some point, so if anyone ever needs a reminder of where exactly to find the exercises, please just ask in chat. Listen, let me just for the sake of it, copy this in as well. Yes. well, that's a bit annoying. Okay, I didn't realise it would it's interpreted the HTTPS as, but it should turn it into a link. Nope. Okay. Well, I would just come to this page. So this is in the first, very first section of the material. Scroll down to the installation section and copy and paste this. And with that, you should have the material, and you can see everything inside this exercises directory is here. So you can just go into, well, we'll be starting off in just a second in O1 arrays. We can see here what we have. Is there anything else that we should cover just now? I think I've already spoken about copying the carpentries methodology. Yes, we've already covered all of this. Okay, any last questions before we move on? I'd say at this point, if anyone's having issues getting logged in, please just hold on, and either in our first exercise session coming up, or in the morning break when we get there in less than an hour, I think by now, we can I can help you then with it directly. But are there any other questions? I think that's a no. Okay, brilliant. Let's carry on then. So our very first lesson is on arrays. I think probably, I imagine most people will know most of this, but there might be a few slightly surprising bits in here, perhaps, for some people. Things that they might not have imagined were possible. I also find this a little bit strange. I'm very used to when teaching, and you start to teach a language and you begin with hello world, what is a variable, this sort of thing. But here we just jump straight in with arrays. So I hope this isn't too big a plunge into cold water for everyone here. Please do ask if there are any questions, and remember there is that link to the and I'll put this in as well, just in case anyone wants this as a reference. The introductory material as well, in case anyone wants to refresh themselves with anything from the introductory course. Okay, but otherwise, moving on with intermediate Fortran. So getting started with arrays. So any array of an intrinsic type. Remember, there are really two different ways to do this in modern Fortran. One is that you can use the dimension keyword and then start specifying the size of each rank. So here we've got rank 2 with 10,2 as its shape, and we're going to call that array A, and it's of course an integer array. And we can also use that, and it's a nice way to specify the shapes of multiple arrays. So here if we wanted to create B, C, and D, all with shape 10,2, this would be the nicest way to do it. You wouldn't have to write 10,2, 10,2, 10,2 every time. The other way, of course, is to specify the shape immediately after the name of the array. So here we have array E, but we're saying this one is not 10,2, it's 10,3. When you do this and you mix both types, what you'll see is that this one, 10,3, is this shape is an override of 10,2. So whatever we put in the dimension is overridden by this. So there's nothing at all wrong with doing that. However, it definitely isn't the easiest way to do it. It's not the quickest way by eye to when you're reading through code, I would say that this is likely going to be a source of a bug at some point, because you will read either this or this and misinterpret one as being the other, and probably and possibly then misunderstand what this means for your arrays. So it's probably best in any one statement to do one or the other. What we do in this course, really just for the sake of style, is to use this way. So if we declare just one single array, we won't bother with dimension shape. We will just put the shape immediately after the array name, and that's just because it's a little bit shorter, a little bit more concise. Of course, if you're working in a code base with others and there's a set style already in place, you should probably follow that. My personal style, and I say personal, is I actually do quite like the dimension keyword, just because I feel that stands out a little bit more. Arrays, so it's important to remember, and this will come up a little bit here and there, that in Fortran, arrays aren't just memory. They really do have they really do have properties like size and shape and bounds which you're able to query, and you can use functions to query all of these. The reason that we're able to do that in Fortran is because they really are a special object within the language definition that says an array, you know, it isn't just the data, it comes packaged along with metadata, if you like, about what their shape and rank and the like are. It's also important to remember how they're stored in memory. Again, this is probably old to everyone here, but just to state again, because it is important, we say that the leftmost index counts fastest. So this is I think a safer way to think about it than talking about things like row major or column major or order. That's the what would you say, perhaps traditional way of talking about this. How are arrays stored in memory? Oh yes, it's a row major language, but that sort of locks you into thinking about arrays as matrices, and while that isn't unhelpful a lot of the time, it does mean it does sort of prevent you from thinking about them in other ways. In particular, I think it can become a little bit confusing when you then sort of shift to things like image coordinates. So you do not have to assign any strict physical meaning to either to any of the ranks in an array. When you're working with an array of rank 2, of rank 5, of rank 7, whatever, you can assign whatever meaning you like to any one of those of those ranks. The only thing that you really should remember is that in Fortran, it's the leftmost index which changes fastest. In contrast, of course, to C, for example, in C++, where you would say it's the rightmost index. But when the leftmost index changes fastest, that just means that in order to do the most performant moves through that array in memory, so that we aren't having to jump back and forth, we can just do nice big loads. What we want to do, if we're, say, doing a loop through them, is have the leftmost index correspond to the index of the innermost loop. So if we've got multiple loops, we want to be changing the leftmost index with the innermost loop, the second index with the second innermost loop, and so on, just to make sure that we're moving one by one through those entries in the array, through those elements in the array as they are actually stored in the memory. And we can, do some wild and wacky things with these arrays. So if we've got an integer of size 5 called A and a rank 2, a real array B, shape 10(2), then we can we can do all sorts of strides through those. So for A, we can start at 5 and go 1 and go up to 5. And we use :2 here to say give us a stride of 2. So that means we're now talking about elements 1, 3, and 5. We can use a vector notation here, 1, 3, 5, as well, and that uses square brackets. This is new. This is Fortran 2008 up. So you may not have seen this if you've mainly worked with older Fortran versions. With rank B, we can again use that colon operator to talk about slices and strides as we like in any or all of those dimensions. It's also worth mentioning that before Fortran 2008, we could only have arrays of up to rank 7. Fortran 2008, now lets us go up to 15. I'm sure there are still some domains out there which would like more, but to me, I think the largest arrays I've ever worked with have actually been rank 7. I'm not sure I have ever actually gone higher than that. But yes, I'm certain some people out there would like even more, but I think for most people, a limit of 15 should be much more than they ever need. And yes, just in case you're doing some kind of generic coding, you can find out how many are in any given array with the new rank function. This is an intrinsic function. You don't need to import any modules to use it. You can just say rank B would come back as 2, rank A would come back as 1. It just tells you how many ranks does this array have. Okay, let's move on to building arrays. Again, there's some stuff here that may be newer to people. I think most people will probably be aware of this way of providing values for an array that you've just created. This is what you do in Fortran 2003 and earlier. You'd start off, you just say bracket, parenthesis, /, and then provide a comma separated list of the values and close with, again, /, close parenthesis, close bracket. Fortran 2008 introduces square bracket notation. You just open and close with square brackets. It's just a little bit easier to, well, actually quite a lot easier to type. Actually, I think this is a strange combination for my fingers, at least, to reach to. You can also use implied do's inside these brackets to fill out those entries. So if you've got an integer I sitting around waiting to be used, you've just declared it. Then inside your square brackets, because let's try and do things modern from now on. Let's use square brackets. So inside our square brackets, let's do an implied do loop. So we open parenthesis, say using the dummy I as a loop variable. Let's start it off at 1 and loop up to 300. So this is going to fill S with 1, 2, 3, 4, 5, all the way up to 299, 300. If we want to mess around with what values are actually going in, we can edit that first term. So we've got, let's say, real T3. Now let's do let's make it so that each of those entries where I is going from 1 to 3 are equal to 2 times I squared plus 1. So you can change the values going in that way. A little bit older, well, actually, I think a lot older, are data state statements. And Yeah, I've only ever come across this in an old Fortran 77 code I had to work with, but I'm sure it's still used. But if you want, you can create a data and then a statement set, and that is really sort of a list of the variables which are going to have values set for them, and then inside a pair of forward slashes, the numbers which are going in for them. So this you will still see. Some of you may even use these to give initial values, but as far at least as the people who work on the Fortran standards and the like are concerned, this is now considered a little bit old. So more modern ways of doing things are what we have up here. Okay, we're starting to move on to, I think, things that may be more new for people now. So allocatable arrays, of course, these are very, very helpful. You just add the allocatable attribute onto the end of your types. So if it's a real, we just say comma allocatable, and then inside the brackets for our new array, we put in a comma separated list of colons, where each colon stands for one rank of the array, whose size we have yet to determine. Then later on, you would say allocate a 1 to n len. So here what we're saying is that a is now going to actually be created in memory. Up until this point, it didn't exist as an array yet. It just existed as an object waiting to have its storage allocated. And we're saying it's of size n len, where n len is an integer. And we're actually being fairly specific here. We're saying that its lower bound is 1 and its upper bound is n len. We could have just put in n len, and this would have had the same effect. It would have said, okay, a is going to have indices 1 up to n len, so it's of size n len. But we could have, if we wanted, changed the lower and upper bounds here. If we'd wanted, if it had been helpful, we could have said that 1 is it could be changed to 0 and n len to n len minus 1, and that would then match C style indexing, which begins at 0. But that's really up to us. We can put whatever bounds we want in here. And we have a question. There's a question in chat. Is n len a parameter or a variable integer? It depends on context. If this were occurring somewhere inside a function, say, or a subroutine, then n len could have been a variable, a dummy, which is passed through to it. So n len could be coming from outside this if it were in a function. And so we have no way of knowing ahead of time until we actually call the function what n len is, but then we call the function and we say, okay, I'm going to call create array with an n len of 50 or 300 or whatever. Then it would create that. But it could also be a parameter. If up above we had integer comma parameter n len equals 50 again, then it would be set that n len equals 50. Yeah, it doesn't matter as long as n len is just a name with a integer attached to it. Then we can use it in whichever context we need. Okay. Yes, once we're done, we should deallocate. So you can get by skipping deallocate if your variable, if your array goes out of scope. So if you're inside a function or a subroutine and you leave, it should be deallocated anyway as soon as you head out of it again. Personally, I like to always try to put in deallocates, just because I feel it's then a nice sort of set of bracketed commands. You can say, okay, I can see right away that between this line and this line, I can do things using A, and maybe it just makes me feel a bit safer too, knowing that for sure my my array is actually being deallocated rather than letting it happen intrinsically. At any point, in case you aren't sure if you've got code with multiple branches, or you're going through you're going through, then you can check at any point using the allocated function. You just say allocated A, and that will come back true or false. I have another question. I've seen code where they insist on dealloc and reverse order of alloc. Is that just a policy of code owner or good working practice? I'd say it's a policy of code owner. There isn't any reason to do that. There are certain things where things happen in order. So I'm thinking in C, when you leave scope, things are freed up in reverse order. So they might be inspired by that, perhaps. But I wouldn't say there is any real need to do that. Could there be potential? Is there a potential performance increase from that? If there is, it would be tiny. I certainly wouldn't worry too much about it. I wouldn't worry too much about it. Maybe it makes the code look tidier. Maybe it helps with bookkeeping, perhaps, if you have a lot of arrays that are being allocated, and it's just there to help the coder check that everything is actually being deallocated. But yeah, I wouldn't worry too much about it, no. Of course, if that's what the code style is, then I would still follow it just to make sure that everything does match. Okay, moving on a little further. So this I think really might be new to people. If we have 3 allocatable arrays, how can we allocate them? So these are 3 things that are a little bit. I think it's not quite as clear here. It isn't obvious. So we aren't using the allocate function now to do this anymore. If we know that we have an allocatable array A, and we know exactly what needs to go into it. So here we're using the Fortran 2008 square bracket initialization. We can just say A equals square brackets, whatever is going inside it. We are not anywhere doing allocate A. We just straight away, A equals this, and that will allocate A with the size of 3, and then put 1.0, 2.0, 3.0 into it. So at that point, we could do allocated A true. We can then also do allocate B, and we can use the optional parameter source. Equals A in this case, and that says allocate B so that it has the same size as A. We can also do then C equals B and tell it that it's equal to all elements of B. If we wanted, we could have put some indices here to make it a slice of B rather than the whole B. But all of these will create them and then fill them with these values. And there's a logical extension to that. If we create A with values 1, 2, and 3, and then say later on, will A be will A, we want to add 4, 5, and 6 to that, we can say A is now equal to A all of the original A, and 4, 5, and 6 are going to be tacked onto the end of that. So it will first of all deallocate A, then create a new one with the values 4, 5, and 6 from the end, and set A to that. And that's under the hood. That's going to be doing something like a move alloc to make that efficient. I have a couple more things here. When you increase A length, will B be unaware? Yes, it will. And also a comment might be worth adding. Reallocate on left-hand side is a real pain with GPU coding, as it silently breaks the link between the CPU and GPU copy, and everything goes out of sync. Yes, it would do. It would do. I'm guessing you're using well, if it's in Fortran, I'm guessing you're using OpenMP for that. But yeah, there isn't any easy way unless you're doing. I've seen people. So this was in C++, but I've seen people where they sort of created specialized types. So what you could do, and I guess this will be a little bit more like what we'll be talking about probably on Wednesday, I think. You could wrap A inside a type and set it up very carefully so that whenever you changed it like this, it would then raise a flag that the GPU copy is no longer true, and has to be copied back over to GPU again. So that's how I've seen people do similar things. That was in C++ in a ray tracing code. It didn't work in Fortran. Was that to I guess we can maybe talk about that later on when we sort of reach that area. But yeah, it is a very good point. These things where you change what the name is actually referring to in memory can be a little bit dangerous in these cases. Yeah, this is a worthwhile point. Okay, I'm going to try. I think we do have. Yes, we have some exercises just down here. They shouldn't take us too long, but let's try and move on to them, and then we can have our first morning break. Okay, any other questions or comments on this just now before I just move on there? Okay, great. So I think this is our last section before we do have a couple of small exercises. Again, when you're working in something like C, where your arrays are really just pointers to memory, you can't really talk about what a zero-sized allocation is, because it doesn't really mean much. And in fact, I think I saw some discussion the other day about different compilers and ARCHER2 doing different things here, which makes it even worse. But in Fortran, where objects, where arrays are objects, you can do this. And it's worth pointing out here that these are different things. So when you do an integer, a is 0, this is an array with size 0. In that case, what we put in the brackets here is the size. So we're saying, give me an array called A with the size of 0. If we did 0, 0, then this is actually an array with size 1. It's just that one element has an index of 0. So what you can do is you can use it to write generic code where you don't really have to care about these edge cases so much. But it does mean you need to also take a little bit of care that zero-sized arrays of the same rank can have different shapes, because what you can do is you can have things like integer C 0,3 or 0,3,2, in which case you've still got zero-sized arrays, but they have different ranks, so they may not actually conform if you start doing array operations. So it's something that's still worth bearing in mind, that they may not actually conform, even if they do have a size of 0. Yeah, and because it has no elements, it doesn't matter if there are actually numbers in there or not, because there are no numbers which can actually fit in it. It has a size of 0, so it's always defined. Okay, that's just a little aside. So I think this is hopefully the only section. This is just bringing everyone up to speed on how arrays work in Fortran. And then we'll be moving on to some more advanced Fortran using this in just a bit. So here's something we can try just now. So our first exercise, and here we go. So in our terminal, so episodes, files, exercises, 0 and arrays, we've got 3 programs in there, and you can compile these on ARCHER2 using FTN. I'll talk a little about what FTN means. And if we look at them, each one needs something done to it. Problem 1 needs to be completed, that something needs to be done to it. Problem 2 needs to be fixed. Problem 3 will fail at runtime, and it's up to us to say what actually is the problem with it. So let's spend 5 minutes just now trying this out. I will actually, just for the sake of it, show how we can do this. So let's take a look at problem 1. So if I go over into my terminal, so here I am now on ARCHER2, and I'm in that directory with my prompt shifted all the way over because the path is so long, inside 0, 1 arrays. And if I ls, there are our 3 problems that we're going to look at just now. So as I say, you can compile any of these by doing ftn. Let's just do problem1.f90, and that compiles. And then if you ls now, we can see we've got a.out, so we can do /a.out, and that will run. We could have, if we wanted, given it a name, just call it problem1 by doing -o. Of course, everyone probably knows this already, but just to point it out. And that will then name our executable as problem1, and we can then do /problem1. As for editing it, well, I prefer to use Vim, so I'll just Vim problem1 .f90, and here's the code. And we can see here what our tasks are. Write an array section to print elements 1, 2, and 7 of A, then all elements of A with an odd index, and then the elements 1, 1, 2, 1, 1, 3, and 2, 3 of B. If you prefer, you should be able to use Emacs. I think Emacs is on ARCHER2. Yes, so you can also use Emacs if you prefer, or if you really do not like any of these text-based editors, probably your best bet is to use Nano. You can just do Nano problem1.f90, and you can just change whatever you want. You can just do print star my solution is, and then these carets, these upwards arrows mean press control. So you press control O to save it, hit enter, and then control X to exit again. Okay, so let's spend just 5 minutes doing that. This really shouldn't take very long, and then we can take a look and see if everyone's managed to do this. Okay, if anyone has any issues doing this at all, if you're still having problems getting logged on, or cloning the repository, or if the compiler doesn't seem to work for some reason, please just put a message in chat, or send a direct message to me, or if you prefer, just unmute yourself and speak. Otherwise, let's come back to this in just a few minutes. What I might do, I might just start doing problem one here on screen for everyone, so you can at least kind of see where I'm going with things. I might do it a bit slowly, so I don't just completely give the answer away. Hello everyone. So I've been doing problem one very slowly. I'm hoping that if any of you were having problems, you could see what I was doing and it gave you some pointers along the way. For those of you who were much faster than that, you've hopefully had a chance to go through that and then also quickly have a look at problems 2 and 3. Neither of them are particularly tricky or should have taken much time. Let's just quickly take a look at them now. So if I just open up problem 2 to show you what's here, what is it doing? It's going to initialize T, which has 3 entries, and then print those out. Nothing at all complex again. So let's just have a go. ftn problem2.f90. Oh no, errors. Okay. So implicit none is specified. Brilliant. It always should be. Therefore, an explicit type must be specified for data object I. Issue. Oh dear. We didn't have I defined. Let's take a look. We can see we just went straight ahead and used I here in our implicit loop. Very simple problem. All we have to do is declare what I is. So let's say that I is an integer. Save. Let's try to build again. Great, it's compiled and run, and there we go. Pretty simple. And now let's take a look at problem 3. Now this one maybe might have tripped you up. I think this one is actually a tiny bit of a trick question. I'm not sure about how fond I am of that, but it might be a useful moment to point something out. We said before, let me go back to the material, up above, that if we have an allocatable array, it's called A, we can immediately just say what it is that we want to go into it, and it will allocate it in memory and put those values into it. And then you say, okay, that's exactly what we're doing here. Nearly. Again, I feel it's a slightly a small trick question. If I try to compile that, okay, great. Now let's try to run it. Segmentation fault, core dumped. What's going wrong? Well, let's take a look again. Maybe I'll actually ask, has anyone, did anyone do this and work out what the issue was? Yes. Okay. If anyone wants to put in chat what the problem is, please go ahead. I'm going to put this in. The left-hand side should just be A and not A bracket colon bracket. Exactly it. That's exactly it. Yeah. Let's just check this here. So of course we can see if I try to compile it again and try to run it, all I've done is I've put in what is the allocated status just before we try to put the values in. So at this point, as we would expect, here we say it's allocatable, and then we go in and say, is it allocated? No, of course it isn't. All we've done is we've said A is an array that we're going to define in memory later on. Is it allocated? No, it isn't. Then we say A, and this is the problem, as was just pointed out by Matt in chat, is this here. What we're now saying here is all of the values inside A are now going to equal this array segment here, 1.0, 2.0, 3.0. And this isn't actually the same as what we did here. What's different is this here. There, in here, where it would have worked, where I'll show it's working, is there isn't that bracket colon bracket. What does that mean? What this means here is we're saying A as an object is now going to equal an array of size 3, rank 1 size 3 with values 1.0, 2.0, 3.0, and we're saying A as a complete object equals that. What we're doing here now is something slightly different. We're saying the entries, the elements of a within the object are going to equal this. The problem is we haven't allocated it yet. There is no memory for this colon to refer to. What we have to do is we have to allocate that first, and then we could have done that. So if we just delete these 3 characters, this will now work. So we go from allocated status false to allocated status true with values 1, 2, and 3. And that's just because we've done something different. What we're now saying is A as an object in its entirety is equal to the array that's going to hold these three values in this shape. As long as we were just doing the colon, we're now talking about oops, I'm making a mess of that. We're now talking about just the values inside it, but if it isn't allocated yet, those points in memory do not actually exist yet. So it can be a nice way to speed things up if you don't want to bother putting your allocate statements in, but it also means that you're hiding away the points when that memory is actually assigned to this array object. Whether you want to do that is sort of how much you trust yourself to not skip past this tiny little detail in the future. It may also have implications. So normally, what I say to people is when you're working with arrays, when you're just assigning values, always do this to make sure that you're when you're skimming through code and you see something like, for example, let's say, for example, A equals 1.0. You're just doing something to all the values of A. You have to make sure that you've sort of trained yourself to properly distinguish between these two statements and realize that while they a lot of the time do the same thing, when you're talking about an allocatable array for the first time, they mean actually something very, very, very different, and that's an important thing to be aware of. Okay, I hope that made sense to everyone. There's also this here, and I think actually what I'll do is I'll actually just go through this rather than make it an actual exercise, because I think we can actually just kind of talk about this as a group, I guess. So let's say arrays are self-describing, they are proper objects. So the compiler, as it's going through code, can actually check a lot of things at compile time, can make sure that a lot of the logic going into these operations does actually make sense. Issues come in at runtime, of course, particularly with things like allocatable arrays, where things can't actually be analyzed by the compiler at compile time. But what you can typically do is tell the compiler to do additional debugging checks at runtime to help you. What these are depends on the compiler that you're actually going to be using. So for the Cray compiler, you can use the option H bounds. For G Fortran, you can use F bounds check. And if you add these to the compile commands, it will mean that if you run code and then do something like go out of bounds, you can see that that things aren't actually correct. It will give you a message to tell you about it. So what we're actually doing, this is maybe a good time for me to quickly tell people about this. If you aren't an ARCHER2 user or a Cray machine user in general, is that we have things called progenv. So at the moment, we have a module loaded. Everyone will have this loaded by default when they log in. And that's progenv cray. And that means that when you run ftn, you're running the cray compiler command. Oops. -- version. Cray Fortran version 16.0.1. If I do module load progenv GNU, and I run ftn-ref version again, I'm now getting GCC GNU Fortran. So I've gone from Cray Fortran to Fortran. So where we say here, we have these two options, hbounds and fbounds check. We can apply these to our ftn command. So this is actually just a compiler wrapper. We can apply this depending on whether we have progenv GNU loaded or progenv cray loaded. So I'll keep cray loaded for now. So we've got two things to check using this hbounds option. So let's check bounds compile time. Let's quickly take a look at bounds compile time. So program bounds check implicit none real array 3, first array element array 0. So we can see obviously this isn't going to work. Array having a size of 3 is going to have elements 1, 2, and 3. Array 0 doesn't exist. So the simplest of errors. Let's try ftn h. Just say h bounds. So all we do is h bounds compile time. And we get an error, as we would hope. So this does actually help us. What happens if we don't do hbounds? Not good, is it? So it does actually compile that. If we do a.out, first array element 0, should it have done that? Probably not, but it has done it anyway. It isn't correct code, but because we didn't tell hbounds about it, or rather we didn't tell the compiler to use hbounds, it's gone ahead and done it. And it's one of those horrible bugs. Sometimes it might work, but it probably won't, and there's no real way to tell. Sometimes you can be lucky and it makes you miss that it isn't actually going to work. Okay, then we have the other one, ftn, what's the other one called? Bounds runtime. So let's check bounds runtime. So now we've got a real array 3, an integer I, and then it prompts us to input an index, and it could be anything at all, any integer. So this is something which, of course, can't be analyzed at compile time, because the compiler has no idea, no way of knowing at all what I is going to be. It could be in range, it could be out of range. So if we compile that, let's do hbounds again. With bounds compile time, and we'll give it oops, that's the wrong one, runtime. Okay, let's build that. Okay, so that compiles now. If I do a.out, okay, let's do something that makes sense. 1, great. 2, great. 3, perfect. 4. Subscript 4 is out of range for dimension 1 for array start at line 12 with bounds 1 to 3. So this tells us basically everything. It's saying it's an array with element indices going from 1 to 3, and we try to do something with 4. It was only a warning. Yes, you are correct. It was only. I'm not sure actually. Let's try module load progenv GNU. We can tell the compiler to promote warnings to errors, and that's probably a good thing to do when you're still testing code, when you're still trying to deal with bugs. I would probably always do at least some testing, saying to the compiler, tell particularly warnings of this type to be promoted to errors. Let's just see what happens out of interest with fbounds check. So we've built that again. Let's just try again what happens with 4. This time it's different. It's an error. So you can see this is actually a compiler determined behavior. For the Cray compiler, that's what we were using here. It gave a warning and a fairly helpful message to go with it. With Fortran, it gives an error. It still gives a nice message, and then it gives a backtrace. So this is something that isn't defined in the standard. It's up to the compiler to say, you know, I'm going to treat this as a warning, or I'm going to treat this as an error. But this is something that's very often worth doing. It's very often worth checking with fbounds check, and sometimes this is helpful for the strangest possible cases. Someone the other day was a week or two ago was on Cirrus, our other cluster, and finding that anything being written to standard out was being lost, and this is probably due to something going out of bounds, because it's probably overwriting some protected memory somewhere that was causing that unit to be lost. So that's what we're looking at now. Whereas, yeah, let's just try once. Let's try this without fbounds check. Oops. ftn bounds run time. Okay. Oops. And let's give it that bad index of 4. And it's going to just give us garbage data now. It means nothing. The code is running perfectly well, but it doesn't. It isn't checking that our index actually makes any sense. So it's now basically reading garbage garbage memory. Okay, I think sometimes. I think Cray sometimes does something strange. And which one is it? They have different. I can never remember. One of them uses something like 105 as well, or 99 or something. A really big, a big number in comparison. It's something. Yeah. So yeah, that's something else that the standard doesn't actually say anything about what those units are. It says the units should exist. They should be different from each other, but it's up to the people writing the compiler to actually say what integer is it under the hood. Yeah, that's a slight divergence from what we're talking about here, but yeah, going through. Okay, does anyone have any questions about this? No worries at all. It's always good to chat. I think it's nice to just, you know, if anyone has any points of interest, you know, anything at all which you think is cool or interesting that anyone wants to bring up, I would say please do put it in chat, and let's talk about it. Okay, yeah. Any questions? Otherwise, I think we can stop for maybe our first quick break. We'll maybe take 10 minutes, maybe do the next section before lunch, and then have a break. Yes, exactly. Yes, Fortran env will save you a lot of problems. Yes, we do cover this in the intro course. I think pretty early on. I think we actually do introduce it right away. Yes, we do. Yeah. So yeah, in the intro course, we say don't, you know, try and not use star and things. Use your ISO Fortran env to do as much as you can and save yourself problems. Okay, right. Yes, so right, 6 star. Yeah, yeah. I would. Yes. I mean, let's say for the sake of it, if anyone wants to run and grab themselves a tea or coffee or whatever, let's come back at 12 p.m. and do a little bit more before lunch on arrays. We'll try not to go on too long so that people aren't held back from having something to eat. But yeah, for the sake of yeah, right, 6 star. I would say always, Mark, for your comment, I would recommend if you want to, I would go for this. Use ISO Fortran end and then use output unit, and that makes sure that you can always take this code wherever you want, because otherwise you'll write 6 star. If you do that, if you're doing that on ARCHER2 and you go from module load plugin Cray to to GNU, that will stop working, because that 6 doesn't mean anything anymore. It'll probably create fort.6 as a file, and then you'll have it being dumped to file instead. ISO env is modern. Yeah, but there are a lot of new modules now that were brought in 2003 onwards. They brought in a lot of modules. Not all of them I think you need to worry so much about, but ISO Fortran env is actually a really nice way of making sure that your code is really portable. It also includes the kinds for different ints and reals. It really makes sure that you can write your code and take it from here to there to anywhere at all, and it will still run the same way. So yeah, for anyone who really cares about this, I'd say really, just take a quick look at ISO Fortran env. It isn't a big module at all, but it's really helpful, yeah, for just making sure that your code runs right anywhere. So yeah, it's just something maybe you just quickly want to take half an hour to look at, and it's pretty simple, and it's very, very helpful. Okay, but with that, let's take a quick break, just 15 minutes. We'll come back at 12 o'clock, and we'll move on then with. Oh, this is the wrong one. That's the old. That's the to arrays as arguments, where we'll just be talking a little bit about assumed shape and the like, automatic arrays, and moving allocatable arrays around. We may not get through all of this before lunch. I don't want to hold people up too much before lunch, so we'll maybe just do half an hour or something of this, maybe not too long, and then just carry on as we need in the afternoon. But yeah, see you at 12, everyone. Okay, hi again, everyone. I hope that was a nice wee break just to stretch your legs. Hopefully have something nice to drink to keep you awake. Okay, let's move on with our next section. So we're still sticking with arrays a little bit longer, talking now about arrays as arguments. So we'll talk about what that really means when you pass arrays through to different program units. In particular, think about what about when they are allocatable, because that introduces some different rules that you need to be aware of. So getting on with things. So most of the time you can get by with just passing arrays directly through to a new program procedure, and trusting that it will be created correctly if it is being created, or just passed through by reference, or equivalently by reference. We'll talk a little about what that means. But sometimes you need to create them with an interface. If you are aware of interfaces, hopefully you are, you can probably think, well, okay, yes, but if I put my procedure in a module that comes with an interface, it's generated as part of the module, isn't it? And the answer is yes, but sometimes you do still need to actually write a full interface to make sure that the compiler knows what it's doing when it handles these arrays going through the argument list. So sometimes you need to do things extra anyway. So when you pass in, when you pass the array explicitly with its shape, this is sort of, I guess, the most passing every piece of information through possible with the array. This is I wouldn't call it an older way of doing it, but it's relying on you being quite explicit about things here. But if you're doing this for a lot of ranks, so if your array here, A, had, let's go with the full 15 ranks, then you would be passing through, let's say, nmax1, nmax2, nmax3, up to nmax 15 or some, or however many ranks you do have, just to make sure that your array is the right size. That it's treated correctly when it appears here inside your subroutine. So what maybe is a little less verbose, taking more advantage of the features in the language, is to treat the array as being assumed shape. So this is what I would, again, slightly hesitantly call a little bit more modern, slightly hesitantly. In that case, you just pass the array through. So we've just said that we've got an array, it's called A, and the only thing that we tell the compiler about A at this point is that it's going to be rank 1, well as its intent on the side. But we say it's going to be a rank 1 array. How big, what is the actual extent of that one rank? We aren't saying anything about here. Instead, we have to deal with that programmatically using L-bound and U-bound and whichever other intrinsics size or the like that work for us in this context. What is important is that it's the shape that is passed and not the bounds. So when you retrieve these, what you get is something with the correct shape, but it's going to be assumed that whatever bounds it has start at 1 rather than anything non-default which you may have given it. So the example here is that there's a real array, it's called A, and it has these bounds on it, starting at 0 and going to nmax. So it's got a shape of a size rather of nmax plus 1, and we then pass it through to the same subroutine, array operation A. When it appears here, it's going to go, okay, great, we've got an array of size nmax plus 1. Its lower bound is going to be 1. Not the 0 that it was originally up here. So you do need to take some care that your dummies inside the subroutine here, that you specify them with the correct lower bound at a minimum, if that's something which is ever not going to be 1 in your code. So we have an example here. A couple of challenges. We'll just spend a few minutes on this. So as a simple illustration of the problem, the following should print out the values 0.0, 1.0, and so on. So not starting at 1, it's meant to start at 0. That's in example 1. What needs to be done to correct it, and we want to keep the declaration 0 to 3. So we want to keep our indices 0 to 3. So let's just take a quick look at that. And then I'll give everyone a few minutes to have a go at this and see what happens. So on in our directories, in our git clone of the repo, let's go down into the 02 arrays as arguments directory. Hit enter, ls, there's our example 1. So let's just vim example1.f90 and take a look. We have a program, assumed shape, implicit none. real A 0 to 3. So we want to keep this. We want to keep our array A having the bounds 0 and 3. Then we're going to call the subroutine initialize on it, and then print out all the values in it. Initialize takes that, it's assumed shape, so it takes array of rank 1 and then loops through it and sets and it loops through however big that array is, because it's saying L bound array dim 1, U bound array dim 1 are its lower and upper bounds of this loop, and it sets each element of array to 1.0 times I, and then we come back. So if we quit, I will again just quickly show example 1.f90, and then I do /a.out. I'm not bothering to name the output executables anything funky, because it's just a little bit slowing down. So if I run that, I get the values 1, 2, 3, and 4. And of course, we don't want that. We want the values 0, 1, 2, 3. That's what we're really after. So the issue, A 0 to 3 is coming out in here as, well, it's coming out as array 1 to 4. And we can actually check that. Let's just quickly do that. So again, in the carpentries, methodology, I hope everyone is doing this along with me at the same time. Maybe you're racing ahead, in which case feel free to chime in with any ideas. But let's just do print star. We'll do exactly the same. L bound array dim equals 1, and I think we can kind of expect exactly what's going to come out here. If I compile that and run it, it's going to tell us here's the L bound. It's 1. The issue is that here we had a lower bound of 0, so we overrode the default in Fortran, where all our arrays would start with an index of 1, and said, no, this array A is actually going to start at 0. And there's probably a very good reason we would want to do that in real life. Maybe we're doing values across a grid or something, and in that case we would want to start out with an index of 0 to be the starting point where we haven't shifted at all. Maybe it's offsets from some position or something. But here we say A starts with an index of 0. When we pass it in here, we end up with, let's just add again. We can actually leave this out. Oops, no. We just get an array out of this instead. And what we're now getting are bounds of 1 and 4. So the question then is very simply, how would we fix that? And it's a very, very simple fix, thankfully. If anyone wants to shout it out, please go ahead. Any ideas from anyone? Past the lower bound? Do you mean pass the lower bound as an extra argument? Okay, yeah, we could do that. The solution here actually assume, so okay, it does require a little bit of an assumption, but let's assume that whatever initialize is doing is always going to be used in this context, and I think that's probably a fair assumption. If our array were representing this grid, say for example, it's some grid in one-dimensional values across whatever range, I think we'd be safe to assume that it wants to start from whatever the 0 point is. So what we would do, I can see there's another comment, let's just get to that in a second. If we could actually just put it there. So in this case, what we'd say, because here the assumption is that initialize is always going to be used for this one purpose, if we set here that the array is actually meant to start with an index of 0 and then extend up to whatever the upper bound is, it will do that for us. And if I try to compile this now and run that, that now gives us the correct answer. We can see the L bound and U bound have changed, and the values in it have shifted the same way, because that's also what our loop was going over. And then the comment, yes, passing the lower bound as an extra argument, because I want any array to be initialized even from non-zero lower bounds. If that was your use case, if you wanted to have this work for any arbitrary starting point, then yes, that probably would be the way to do it. Yes, you would say, let's have an extra let's call it I start, let's call it, for example, and then you just have integer intent in I start and have I start there, and you would then do 0. Oops. This would also work. What's critical is that we get this, is we get something inside here. We want to be able to tell it, yes, it's assumed shape, so let's not make any assumptions about how big it is. We're just going to say it's rank 1 and its indexing should start from this specified point. That's what's important. So if I compile that will hopefully do the same thing. Yes. And as you say, we could then change this to -10, for example. Let's just see what happens. Hopefully it will still do the, still do the right thing. Yeah, now it's going from -10 to -7. So that's what we wanted to see. So yes, anytime you need to do this, you just need to somehow say what is the starting point for the indexing. Most of the time, I would say probably you can just set this to some constant value, because probably your function or subroutine is doing one specific thing. But yeah, if you did want it to be really general, then yes, you could just pass it as another argument. Okay, any questions on that? Otherwise, we have another challenge here, just a bonus. I actually touched on it without meaning to when I was speaking back there about what I was doing. Okay, let's just quickly ask this question. As a bonus question, why did we have to put dim in L bound and U bound? Just a very quick bonus. Why did we bother with doing this? Array only has one rank, so why are we bothering with dim equals 1 here? I'll just give maybe 20 or 30 seconds for people to think about this if they aren't sure. If anyone knows, please do go ahead and type it in chat. Assumed size and not assumed shape? No, that isn't the reason. It's something you maybe it does make sense once you realize it. Okay, I'm not seeing any other answers. It's actually kind of very simple. It's something which I actually forget more often than I would like. Yes, Ewan, that is it. That is it exactly. So if you don't tell L bound or U bound what the dimension is, what it actually returns is not a scalar integer but an array, and that array is of the size, is of the bounds of each of the dimensions in order. So even though this is only a rank 1 array, if we didn't include dim equals 1, what it would actually give us would be an array of size 1, a rank 1 array of size 1, which would just include well, 0 and 3. in that array. That's perfectly fine. We can get that number out. It's just that here, all we actually want is that scalar value itself. I'll actually just quickly show this. Let's just quickly go here. Let's just delete the dim equals 1 from these two, and I think this should show us. This should show us what we're talking about. No, it's being clever. It's being clever. Which one do we have? I wonder if the Cray compilers might show it differently. They may show it. It depends how clever they are. No, about formatting it. But when we do this, L-bound array is actually returning an array. It's just a single value in it, which is just whatever the lower bound is or the upper bound. It just makes it slightly more difficult to use it in this context here, where all we actually want is that scalar, that value to go into I. Okay, and I believe, rank 1 array. We just want the scalar. Okay, are there any questions about any of this? Otherwise, we'll just do maybe we'll just carry on until about past and then stop for lunch. Okay, I think that's good. In which case, let's carry on. So, moving on now to automatic objects. So automatic objects are objects which are created whenever we go into a new procedure. So in this example, we're going into a subroutine, array operation A. Okay, A is just something that's coming in from outside. But let's assume that inside this array, inside this subroutine, we need a new real array called temp, and it's of size 1 going up to size of A. And in that case, this is a temporary array, so we don't know the size at compile time, only at runtime. That's called an automatic data object, and that's probably going to go onto the stack rather than the heap. It goes on the stack because if you think of the way the stack works, as you call more functions and subroutines, you can put those on top of the stack. Then you can allocate your new automatic objects on top of the stack as well. Remember, the stack keeps everything in order, and then when we leave the subroutine here again, we pop off temp because we don't need it anymore, and we pop off the subroutine itself, and we're back down at the level of the unit which was calling array operation. Part of this means that you can't give it an initial value as part of the declaration. It may not be a good idea. So it says it's generally considered poor software practice that if this is going to be of any real size, you may not want to put it on the stack. Remember, often the stack size is limited compared to the heap. You can, of course, unlimit it, but it can cause issues for you. So what you may prefer is to put it on the heap instead. Assumed size was mentioned in the chat a few minutes ago. Again, this is, I think this is definitely fair to say, a slightly older style, thought of now as an older style of coding, where you use the star in here, and this doesn't contain any information about the shape. It's a lot harder to do things like bounds checking in this case. So it's harder to write code that is self-correcting in any way, or to allow that runtime debugging. So much preferred nowadays is either to go with the explicit shape, where you pass the size of each dimension through as its own parameter, or sorry, I'm scrolling back and forth, or assumed shape, where you put the colons in there for each rank that you're expecting to get, or to just create them automatically if that's possible. Or sorry, not automatically, allocate them. Okay. What you can do is pass allocatable arrays through to your procedures. This is one of the cases where an interface really does have to exist, whether you've written one by hand explicitly, or whether the subroutine is in a module, in which case it will have its interface generated automatically for you. Because if you try to do this somewhere and it doesn't have an interface, and then you call it, the compiler will be very, very displeased with you, very unhappy that you try to pass an array which potentially doesn't have any real memory attached to it yet. If it does have an interface, the compiler will be perfectly happy, because it will understand that. But otherwise, yeah, this can be problematic if there isn't an interface. There are some conditions which come attached to this. The actual argument coming through to it also has to be allocatable. The rank has to be given, so you can't leave the rank something to be guessed. And anything which changes the allocation status of the argument must happen by the dummy. So this means that what you really need to do, again, in practice, when it comes down to doing this, is that when you receive an allocatable array through here, you probably want to put some kind of guard in where you check with the allocated intrinsic function. Remember, just returns true or false depending on whether A is allocated or not, to determine how you handle it, just to be sure. And intent matters here quite a lot too. So if you have an allocatable array, which is a dummy argument, then if it has intent in, remember, this sort of means that it's read only, if you like. It sort of it means it's a little bit like adding a const qualifier in C++, if that's where you're coming from. Intent in means that you aren't allowed to make any changes to it. And that means that you can't change whether it's allocated or de-allocated within the function or the subroutine. And of course, as normal, you can't actually change whatever numbers are in it if it has been allocated. So you just need to remember to think of this as you saying, for the duration of this procedure, this whatever is read only. If you give it intent out, then what might be surprising and what can catch people out is that it's automatically de-allocated on entry, even if it was already allocated. So that means if you had something in it, if you had an array with a size of 100 and 100 very important values stored inside it, and then you pass it to something with intent out, it's wiped clean, ready for allocation or whatever else would happen to it inside this new procedure. So this can catch you out. It's very helpful to remember this, that it will be automatically de-allocated. So if you want to make sure that you keep that data, you might have to use in-out, even if otherwise you wouldn't have normally thought to do so. Okay, any questions about this? Because yeah, as I say, this can catch people out. So any questions about these points just now? Okay. Um, we may just about make it to the exercises. We'll see. Okay. So what we can also do, you can write a function whose result in this example here, A, is also allocatable. This just has one very simple condition, which is that at the point the function ends, so at the point of return, wherever that is in here, that result must be allocated. That's I think much more simple to remember, a much more straightforward point than the previous one. There's also some notes to point out about passing away sections as actual arguments. So let's assume that our subroutine myArray operation takes in a dummy argument A. We'll say it's got intent in out. And just a real array, it does something and then it ends. What you can do is call it like this. So let's just say A is an array of size 5. 1, 2, 3, 4, 5 are the real values which we've put into it. We can then call it like this, and that's perfectly allowed, and actually very handy at times. This is very powerful. It's worthwhile noting how this actually works in practice. So people often talk about the contrast between Fortran and C-like languages as Fortran being passed by reference, as you can do in C if you work with pointers, C++, versus the default of pass by value in C. So sometimes people talk about it as though whenever you call a procedure in Fortran and you give it an actual argument, what you're passing to the underlying procedure is a memory reference to whatever the actual argument is, and the procedure can get to work using that directly. And that isn't strictly true. Sometimes Fortran will do that, and it really does pass by reference, and the memory reference goes through and it works directly on it. But Fortran is also allowed to do copy in, copy out. And that means that Fortran will create a new temporary object, copy the values of the actual arguments into it, then get to work on that temporary, and then copy whatever changes have happened to it back into the original at the end of the operation. So really what Fortran is that it looks like pass by reference, although what it's actually doing may not strictly be pass by reference all the time. And that's what it will be doing here. So it doesn't actually work with the direct A1:5:2 array section here. What it will do is it will create a new array, and it will just be the right size and copy the correct values into it, and it will work with that temporary, determine what the output, what the changes are, and then copy that back into the right places inside A at the end of it, and then delete that temporary array. So that's what's happening here, and it is now 12:30. So let's just quickly do this, just very quickly. Let's just take a look at example 2, and then I think we'll break for lunch. So let's take a look at example 2.f90. We have basically the same setup: array A5, 1, 2, 3, 4, 5, call my array operation 152, and it prints out the final values of 1 to 5. And inside array operation, it sets whichever values have been passed to it as 0. So if we ftn example 2.f90, and then a.out shape, so it says the shape of B is 3, final values, and it's set those equal to 3. So inside the subroutine my array operation, the B that it's working with is really a brand new array, rank 1, size 3. It's into it have been copied 1, 3, and 5 from the original actual argument A, but what we're working with inside here is a new array that just happens to have the correct data in it in the right shape. We work with it, and when we're done, those three values inside B are copied back into elements 1, 3, and 5 of the original array. Okay, right as we finish for lunch, any questions about any of this just now? Now's your chance. Okay, I think everyone's happy. So what we'll do when we come back from lunch, we'll actually spend just a few minutes doing this exercise, just to finish off what we're doing on arrays, and then we're moving on to pointers, slightly more esoteric, I guess, in Fortran land. So yes, so this will be what we're doing after lunch. If anyone wants to have a go at this during lunch, or even just to take a quick look at it to familiarize yourself with what we'll be doing, then please go ahead. Otherwise, let's finish now. We'll come back at 1:30 and carry on. So yes, we'll take a full hour for lunch. We can check our emails, get something to eat, and so on. I'll be online almost all that time. So if anyone does have any questions about anything, or if anyone's still having issues getting logged on or just using the compilers or anything at all, please do just send me a quick message, and I'll be really happy to help you out fixing that, or helping you understand things. Otherwise, I hope that's been a good first couple of hours of this course. Enjoy lunch, and I will see you again at 1:30.